Hi all, here we're going to use reference angles to rewrite a trig expression. So here we have to rewrite expression as a function of a positive acute angle, and acute means less than 90 degrees. The easiest way is to actually plot the angle. We have tangent of 280 degrees. So just quickly jot down the x and y axis. So we have x, we have y. I am going to label the benchmark angles. So positive x-axis starts with the 0 degrees, then we have 90 degrees on y-axis. Negative x-axis has 180 degrees, then negative y-axis has 270 degrees, and we are back to 0, which is also 360 degrees. You don't have to draw the angle precisely, but you should be able to tell that 280 degrees will be somewhere between 270 and 360 degrees. So this is our 280 degrees. The reference angle, just like a reference triangle, is always made with the x-axis. So how many degrees does this angle make with the x-axis? It's always with the x-axis. So if this is 280 degrees and the whole circle is 360 degrees, the best way of finding this would be to take 360 degrees and minus 280 degrees. We get 80 degrees. So let's begin rewriting this expression. So this expression will be equal to, before I use the reference angle, I need to know the value of the function. So all trig functions are positive here. Sine and its reciprocal cosecant is positive in quadrant 2. Tangent and its reciprocal cotangent is positive in quadrant 3. And cosine with its reciprocal secant is positive in quadrant 4. Since the angle falls in a quadrant 4, and we are working with tangent. Tangent will be negative in that quadrant. And now we are still working with tangent. And the reference angle we got was 80 degrees. So tangent of 280 degrees has the same value as negative tangent of 80 degrees. And this is our solution. Here we have to rewrite the expression as a function of a positive acute angle as well. And we are working with cosine of 137 degrees. So let's jot down x and y axis. So we have x and y axis. Positive side of the x-axis is the 0 degrees. Positive y-axis is 90 degrees. Negative x-axis is 180 degrees. Negative y-axis is 270 degrees. Back to the x-axis, we get 360 degrees. So our angle is 137 degrees, and you should be able to tell that it's somewhere in between of 180 degrees and 90 degrees here. So this is our angle of 137 degrees. The reference angle is always with the x-axis, so we are looking for this piece. If I know that this much is 137 degrees and a straight line is 180 degrees, so from 137 degrees, how much more do we need to get to 180 degrees? And the calculation is simple. We do 180 degrees minus 137 degrees. and we get 43 degrees for our reference angle. So let's figure out the sign of our trig functions. So all are positive here, sine cosecant is positive here, tangent cotangent is positive here, cosine and secant are positive here. So if only sine and cosecant is positive in quadrant 2, our cosine of 137 degrees will be equal to negative cosine of, and the reference angle was 43 degrees. And this is our solution. Now, you are not always subtracting from the benchmarks. Let's do a similar example. Let's say we have cosine of 237 degrees. Now this angle would have fallen in quadrant 3. So this would be our angle over here. So the whole thing would have been 237 degrees. We would be looking for this piece. And in order to find that reference angle, you would have had to take 237 degrees and take away 180 degrees. You would want to take away the overlap, and our reference angle would have been 57 degrees. In quadrant 3, cosine is negative as well. So cosine of 237 degrees would be equal to negative cosine of 57 degrees. Just to summarize, so let's say our quadrants are 1, 2, 3, 4. If your angle theta is in quadrant 1, the reference angle is the same as the theta as is. There is nothing you have to do with it. If your angle happens to be in quadrant 2, to find reference angle theta, you would take 180 degrees and you would minus the angle. That will give you the reference angle. If the angle falls in quadrant 3, the reference angle can be calculated by taking the angle and subtracting 180 degrees. And if the angle is in quadrant 4, to find reference angle, you would take 360 degrees and you would minus the angle. And that would give you the reference angles. These are the formulas for degrees, which are pretty easy to do by drawing the reference angle, but you can apply this method to finding reference angle in radians. This would give you reference angle in first quadrant is equal to the angle itself. Reference angle in a second quadrant is pi minus the angle. Pi radians is equal to 180 degrees, so the method is still the same. In third quadrant, the reference angle can be calculated by taking the angle and subtracting pi. Just like in degrees, you took the angle and you subtracted 180 degrees. And in fourth quadrant, the reference angle is 2 pi, which is equivalent to a circle, or 360 degrees. And you minus the angle that you're given. That's all.